Welcome to the SEI Podcast Series, a production of the Carnegie Mellon University Software Engineering Institute. The SEI is a federally funded research and development center sponsored by the U.S. Department of Defense. A transcript of today's podcast is posted on the SEI website at sei.cmu.edu/podcasts. In this series of podcasts, we are presenting excerpts from a recent SEI virtual event, Is Software Spoiling Us? Jeff Boleng, Acting Chief Technical Officer, moderated the discussion, which featured a panel of SEI researchers, Grace Lewis, Eliezer Kanal, Joseph Yankel, and Satya Venneti. In this segment, our panel discusses some awesome innovations in daily life that are made possible because of software.
So we're going to start today. I'm going to start with Dr. Grace Lewis. She's a principal researcher here at SEI. She focuses on a wide variety of things from IoT security to cyber foraging to something we call cloudlets here at SEI. But Grace, first question, and we're going to go around each of them and give everybody a chance to answer this, about what is something awesome in your daily life, not your DoD or government life, but in your daily life, that something awesome that software, some awesome capability achieved through software.
Right. So to me, it's amazing that nowadays we have these personalized, context-aware internet services, and that they can be composed with things that exist today. So I was just reading something over the weekend, and it made me think about this smart grocery shopping, which is something that is perfectly achievable today. So you can imagine a scenario in which a user has a smartphone, and the user says, "Okay, time to go shopping," right? And the smartphone sends our user preferences to the smart grocery shopping services. It sends its location, and basically what the smart grocery shopping service does is put together a grocery list. And how can it do that? Well, it can use elements from my smartphone, look at my smart pantry, smart refrigerator, and tell me what grocery items I'm missing.
Do you have a smart pantry?
I'm working on it.
Okay. That's cool.
It can use publicly available data. It can use map data to see where stores are located. It can go through store ads. It can look at traffic information. It can use commercial APIs. Lots of stores have APIs nowadays, and you can use a commercial API to say, is this item available and how much does it cost? The service on top of that could use what I call the smart internet. I like cooking. Actually I don't, but I like cooking, and and it knows that I browse through these recipes, and I mark this recipe as this is something that I would like to make this week, and so it can grab ideas and items from that. In addition to that, the smart service can say, well, I mean, sure, I know you like actually going shopping to a brick and mortar store, but there might be something cheaper online. It can look for items online. If they're cheaper, it can buy those and pay for it with your credit card. And so at the end of this personalized context-aware internet service, what I have on my smartphone is a grocery list. It has a list of stores, and it has what I should buy at each store, and they're all within 10-mile radius of my house because that's what I told it to do. And this is not science fiction. It's something that is perfectly feasible today. So what are the technologies that are enabling that? Well, there are lots of them. So first of all, massive data mining and storage enabled by cloud computing. Lots of data in the cloud, lots of just data mining capabilities, algorithms that try to make sense of all the data that's out there. So not only thinking beyond just looking through my recipes and see what I like to cook, but beyond that. Internet of Things, big thing nowadays, and people are getting very, very creative with the devices they can build. Lightweight operating systems that you can put on very small single board computers, and you can all of a sudden you have a smart pantry, going back to your question. Right. Virtualization, microservices, that's how companies are putting their APIs out there so you can use them in your applications. Mobile devices, I mean, smartphones are getting smarter and smarter. Onboard connectors, connected sensors, things that you can plug in, weather to measure water quality, air quality, Fitbits, health meters, whatever. So again, these technologies are all available today, and being able to build these apps, and like you said, not knowing that I'm using all these services from everywhere, and it's just amazing to me.
Yeah, I mean, you truly get penetration with the technology when it becomes ubiquitous, and you forget that you're interacting with it. So, all right, we're going to go to, thanks, Grace. That was a highlight of dozens of things of cool things we're leveraging. All right, we're going to move to Satya Venneti. She's a senior research scientist here at SEI, and one of her primary areas of focus is machine emotional intelligence, or having machines help understand what the state of the human being. So, Satya, what give us some awesomeness that software brings to us.
So I'm really excited about machine emotional intelligence, and really, I think of it as a shift from the information age to an actual communication age. So it's actually able to, machines are able to detect, understand, and respond to human users' emotions in real time, and that can actually help in many ways. So I kind of listed 4 here, which is human-human teaming. So it can actually help humans interact better with humans, and so. There's one startup out there called Humanize, and it came out of MIT. And they have these ID badges which actually have sensors on them. And they are in real time able to transmit stress patterns and movement and so on. And so they actually help to understand how employees are engaged and improve processes and so on. So they're actually using it on Wall Street to actually look at how their bankers are being stressed out. So I think that's amazing. And then the other thing is human machine teaming. So again, there's this startup called Break, or BRAIQ, which is actually, like they have these self-driving cars and they equip them with sensors, and they're actually, actually looking at how people feel when they're in these self-driving cars, and actually, looking at how comfortable they are when they're accelerating or braking or so on. And then the other one is augmenting human capabilities. So again, there's this startup from MIT, and it looks at speaking patterns. And it's actually able to help call center agents to engage better with their customers. Like, hey, you're speaking too fast, or you're actually speaking over each other, or you're interrupting each other. And then the last, and my favorite, is offsetting human limitations. So there's this actual app called SAM, and researchers are actually seeing if teens are suicidal by actually looking at their patterns of social media and so on. And that's a big problem out there today. I think girls, actually, teen girl suicides is, I think, at a 40-year high. And so this is something that I think, machine emotional intelligence is really helping to actually look at how people interact with each other, machines, and so on. I think that's great.
So what kind of technologies power all these innovations?
So there's something called passive biometrics. And it's this new generation of biometrics where we actually are able to look at people and, actually without contact, we are actually able to see and collect biometric information in real time and actually analyze that in real time. And the drivers are that on the front end, we have these low-cost, high-speed, high-resolution sensors that are available. And on the back end, we have new technique software, actual signal processing, image and video processing, and so on. And of course, big data analytics, that you can take all this data and crunch it in real time and see how the person's feeling in real time. So I think this is the main driver for this whole, machine emotional intelligence.
Awesome. Thanks. I think it's time. Now we're going to go to Eliezer Kanal. He's a tech manager in our cybersecurity division. And Ellie's built a data science team that's pretty formidable for us here. And he leads that and is one of them too. So same question. We're going to get through all 4 of us on this question, or all 4 of you on this question. What's some examples of awesome things software capability has brought to society?
So there's a couple. One of my favorite ones, that I'll start with first, is the success of the AlphaGo software in being able to not only play a game that is exceedingly difficult, exceedingly abstract, a huge number of possible moves, but it's also able to actually behave with what we would refer to in humans as creativity. So we're starting to see the machines not only, the software is not only able to perform a task it's given, but come up with new ways to do the task, and that literally outshine what the humans have come up with before. And that coming out of something which we've built is really pretty impressive. The people who build these almost refer to it as their children. They're watching their child grow up to do something pretty impressive.
Yeah, I read that the win for AlphaGo was a strategy that no human
has ever
seen before.
I don't know much about Go, but I remember reading them discussing it, and they say that in the middle of the game, the software placed a piece in somewhere which didn't make any sense, so that any of the people who were watching it, they were wondering if it was a bug. And as they finished watching the game unfold, this enormous, beautiful strategy came out. And you hear the masters of the game who've been playing this and are international champions were describing it as incredibly elegant. And they were expressing the sort of amazing admiration for the software the same way they would be some of one of their human peers. So it's a pretty impressive achievement.
So that topic is enough for a whole nother webcast, but it brings up a lot of questions like, is it repeatable now?
So it's interesting. So let's get to that. So one of the other areas where I think we've seen some extreme impressive advances are in the areas of self-driving cars. People don't tend to think of it, but a self-driving car is much more difficult than just put a train on the track and put a robot on the speed pedal. There's an enormous amount of freedom. The car could drive on the curb. There's an enormous amount of social mores to have to take into account. If a person's coming down the street, a human driver will slow down a little bit to indicate they've seen the person, even if they don't need to slow down. That kind of behavior is very difficult to train into a machine. Right. So the ability to do that has really, it shows kind of how far software has come, that we're able to train the machine not only to behave and perform the task, but to perform the task in a way that it can actually interact with the human peers where the robot is going. You asked before about some of the technologies that underlie this. There's an absolute ton of them in the field of machine learning, but just to focus on one for a second, there's something called a recommender engine, which can look at other types of, what behaviors have you done before? And based on what you did before, we were talking earlier about shopping. Based on what you've done before, it looks like you might like this thing. You've never bought that before, and in fact, this may not even be in an area where you're familiar, but other people who've liked what you've liked have liked this. And these advances and the way they've implemented them have really kind of brought some of this stuff into the next level.
I love recommender engines because I hate shopping. And I want to go to the website and I want to say, I want something like this, and all the other crap I bought. Give me the thing I'm going to be happy with, and it does. And I love recommender engines, actually. Okay, so last time for this question, we're going to go to Joe Yankel. He's a senior software engineer in our cybersecurity division, but he really focuses on secure DevOps. So Joe, I think Joe's going to tell us about how DevOps saved healthcare. No, I'm kidding.
Well, actually, I recently did read an article where I watched a presentation on a fellow who was brought in as a contractor. He worked for Google at the time. His name is Mikey. I forget his last name. Sorry, Mikey. He's now the head of a new department established in the White House, digital services. And he was brought in. Healthcare is a big thing, right? Health reform hasn't been really attempted in decades. Administration does, and they're on the line to get this up. And what happens? Well, 4 million people try to register the first day. The site doesn't work. They wanted to save it. They brought in a team of people. They came in and looked at the situation and said, wow, well, let's look at the monitoring. Well, we don't have monitoring. We can't tell you what services are up, what's down. We have no idea how to do this. And his thought was, well, let's apply the basic techniques of DevOps. Let's get in there. Let's get everybody together in a room and work through the problems iteratively, one step at a time until it works. 3 months later, there's 8 million people enrolled. Big success. We do focus on DevOps. It's unique for every company. There's not really a standard path. There's not a tool that works for everybody. You have to come in, assess the situation, which could be unique for every organization, every business, and come up with a plan that works. And it involves quite a bit of communication. Communication's key. It's something we've been practicing here with our customers and the DoD, and it's been working. It allows for us to practice. We practice Agile. Agile hasn't been typically done in software acquisition. You spend a lot of time with requirements. You propose a solution that will deliver a product in 3 years. A lot of things change in 3 years. Security requirements, technology. The old way of doing things doesn't allow for...
2 generations of processors happen in 2 years.
Right.
Yeah.
And so we want to be iterative in Agile and DevOps. We need to restructure how we acquire software, how we commission the building of software to allow for new technologies, new ideas, new requirements. And so our focus has been on Agile and DevOps, and that does allow this to happen.
Yeah, so Joe introduces, actually, I'm going to not let myself off the hook. I got to talk about something that I think is awesome that software achieved. So I have 2 examples, actually. The one example a lot of people that know me have heard me tell this is I'm not fortunate enough to own a Tesla. I wish I was. But in 2014, there were tens of thousands of Teslas made that had adaptive cruise control. Pretty cool technology if you've ever been in a car with adaptive cruise control. It's a really neat innovation that keeps you safe and keeps you at the same distance behind somebody. 2 years later, while those cars were tucked in their garages, nestled, silently for the night, an over-the-air software update happened that gave them almost complete self-driving capability, at least on the highway anyway. It's not full self-driving, but it was 2 years after those cars were produced, a software update allowed a significant increase in their capability. And I'm just floored by that we're able to do that now. No technician came to the house, no new sensors were added, no new hardware, nobody bent more metal. So that's one example. The other example I think is a little bit quirky, I guess. In 2013, there was a Vietnamese kid named Dong Nguyen. In 3 days one weekend, he wrote a piece of software that 6 months later was earning him $50,000 a day. And that was Flappy Birds, right? If we all remember the Flappy Birds application. Yeah, 3 days. He wrote that thing in 3 days. And so one of the lesson there for me is what enabled him to write that, to write that software so quickly that could achieve such significant impact. It really, it didn't cure cancer, but it had significant global impact. There was probably an awful lot of productivity lost because of Flappy Birds at work, right?
Thank you for joining us. Links to resources mentioned in this podcast are available in our transcript. The complete webinar, Is Software Spoiling Us?, is available in its entirety on the SEI's YouTube channel. This podcast is available on the SEI website at sei.cmu.edu/podcasts and on Carnegie Mellon University's iTunes U site and the SEI's YouTube channel. As always, if you have any questions, please don't hesitate to email us at info@sei.cmu.edu. Thank you.